one of the things when we start looking at this Hodgkin-Huxley structure, particularly a Hodgkin-Huxley structure that you could actually do on the FPAs, such as in this SoC FPAA approach, we really want to ask the question, well, could I actually build an example that has all these Hodgkin-Huxley neurons on it? And this was actually very important from early on to do that. And so what I wanted to show was just a short sort of high-level view of what the tools look like. Obviously, this is all sitting in a virtual machine. This is all Scilab and XCOS. This is actually the block diagram for the Hodgkin-Huxley structure, which basically has a couple key parameters in it, which includes ENA, EK, and sort of an overall bias term for the input current, as well as an arbitrary input element. There's a couple parameters in the Hodgkin-Huxley neuron. And then from this, we simply could get the output into the ramp ADC. We do actually use this floating gate OTA structure because it sort of takes the signal that's sitting from about 100 millivolts up to about a volt to 2 volts. So basically the way we set this floating gate OTA is set it at a very low gain mode, so it's like 1020, and that just sort of gives us the structure we're looking for. You actually take a look at it from the examples that actually will at various forms of this, but you'll see from an on-chip going on to a Hodgkin-Huxley neuron. From this Hodgkin-Huxley neuron, this would be the block that would come up if you actually compile, program it. Let's compile, program, and then you actually then say take the data. The plot you'll see is a nice sort of set of action potentials coming off. Obviously, it might be a little bit different depending on a little bit of the mismatch structure, depending on whether that's been accounted for or not. If it has, then it should be absolutely identical. Otherwise, you're going to get a very, something very similar, and you just tune the parameters a little bit, and you can find it.